Well, hello there, said Qui-Gon Jinn. I don't know why I said that. I have no idea why I don't know why I say anything much. Yes, I am in a strange mental place today. Very strange. Okay. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Welcome. Hang on, I've just got to log into Better Portal because I did not have that open. I am typically unprepared. Live stream. Oh, that's the one I want. Clicking on the thing, in the thing. All right, I better get chat open too. Pop out chat, change it to live chat. You are seeing live me doing all the last minute getting ready thing. Okay. Good morning to Scott. Emmy is here. Amanda, David Howes, David T, The Lane, Luminator, good morning, Gavin Jackson, Stephen W, some call it fun, Any Mules. Hang on, Emmy, I thought I said hello to you earlier. Why are you on the list twice? I don't know.
Man said squirrels.
Squirrels. Tabraze is here. Henrik, welcome. Mike Carden, Jordan, Keith H. Seeing Keith's name reminds me that amazingly, next weekend is barbecue weekend. It kind of catches me
Outside
unawares.
The box said she's extra.
Emmy is extra. So because of the odd alignment of weekends and month ends and all of those sorts of things, sometimes there is a long gap between barbecues. Sometimes it is shockingly short. Feels like only last weekend that there was a barbecue. And now there is one next weekend. Dodgy is here as well. Hang on, this list... it just hasn't updated in that little portal window thingy. Emmy said, I'm on the list twice because I'm a Gemini. Yes. Well, you may hear in my voice that I am still sick. It's been nearly 3 weeks now, and I'm I'm still sick. Definitely improving, but I am not feeling 100%. I am feeling under the weather and a bit of brain fog and tired, really tired. How's the power today? Henrik asked. The power is oscillating at about 50 times a second approximately, and the amplitude of that modulation is approximately 240 of the voltaics. According to the spec, power in Australia should be 230 volts, I believe, but it's kind of done on a state-by-state basis. And anyway, that's a whole can of worms. People will say, in Australia it's 240 volts, or in Australia it's 230 volts. Funny thing is, it's actually determined on a state-by-state basis, and the power companies, they have a certain window within which to operate. And here in Victoria, power coming out of the socket is typically around 240 volts ish. Hope it would be a little more than approximately 50 hertz. Stephen W. No, in Australia, or is it 60 hertz? Oh, I can't remember. Is it the US or Australia? One of them, one has it at 50 hertz, one has it at 60 hertz. 50 hertz mains utility frequency. 230, yeah, okay. 230 volts, 50 hertz versus 110 volts, 60 hertz. Yeah, that's what I thought. So I was right. Jordan asked, are barbecues held on the second weekend of the month? Yes, that is exactly the formula. So if in doubt, the formula is it the second Sunday of the month? So if you're wanting to embody this in code, you would say if current day is second Sunday of the month, then barbecue equals true. So next Sunday, second Sunday is the month. Oh, Stephen W said I meant accuracy. Yeah, yes, approximately. So it depends what sort of error bar you allow for the word approximately to encompass. Some call it fun. If DOW equals 1 and DOM between 8 and 14. Yes. That is one way to do it. What happened while I was in Sydney? Asked Dodgy. I don't know. I didn't even know you were in Sydney. What were you doing in Sydney, Dodgy? Scott said, you sound like how I felt since having COVID. I actually thought I had COVID 2 weeks ago. Like it was when it was getting into the second week of it, of being really sick. I got some COVID tests, and I ended up doing 3 tests. I've done 3 tests so far over the time that I've been sick. They've all been negative, so I don't think it's COVID. The scientist would say it's an error bar of 2%, says Jack's Tech. Oh, Jordan says, great. If we ever get a chance to come visit Australia, we'll make sure to make it the second weekend. Yes, but which would give you the benefit of being able to come to the barbecue. But Jordan, and this applies to everybody else as well, you do not have to visit just on the second Sunday of the month. If you ever make a trip to Melbourne, then you are welcome to come and visit me. So let me know and we will set something up. We'll arrange something. You can have a private tour, a private barbecue. We can cook some sausages and run the sauce bot. Osmains is 230 volts plus 10 minus 6 according to the standards. Yep. Says Gavin. Right. Tech Nebulous is here as well. Good morning. I need to tick a few more people off the list. Steve Ellis, Tassie Bob, Jack's Tech have all appeared. My power is currently... Stephen W says, my power is currently 248.1 volts, 49.9 hertz. Celtic Beast is here as well. Oh, excuse me, that really does not sound good. It doesn't feel good. I'm sure it doesn't sound good. Now, I'm going to pull something up while you can't see it. Yeah, Dodgy says, funny how everyone thinks it's 240 volts, but hasn't been that for a very long time. Yeah. Here comes the text-to-speech. Text-to-speech. Come on. Come on.
Amanda Thompson said, good morning.
That's what I was waiting for. Good morning. I'm going to grab... Oh, hang on. I need to get into email because I want to... Sorry, I am looking through email because there are some pictures to show you, but I want to... I need to do a bit of preparation first. Open a new window. Yes. So, by way of background of what I'm doing at the moment, Amanda has sent me some more pictures of the retractable patch panel Duvalaka thingamajigamy that I can show on the stream, but I just need to do something to them first. Open folder. I want to open the batteries in my in my trackpad have gone flat, and it really highlights to me how much I rely on them. All right, now I just need to get myself a tool because I need to change something on this. For privacy reasons, Amanda asked me to anonymize something. Okay, so that is anonymized, and I'll bring this up here. And where's the other one? Here. Okay, and I will just anonymize this one as well. I know, this is riveting, isn't it? So exciting watching my talking head while I am doing something off screen that you can't see. Okay. What have we got here? This. All right. Now, hopefully that doesn't disappear. So what we are looking at here, by way of a memory refresher, I don't know if I still have those images. Was it last stream? I honestly can't remember. I have lost all sense of time. We were looking at retractable patch leads and the thing that Amanda has been designing, which is, yeah, anyway. Oh, sorry, I was just looking for the other pictures which showed the renders.
Anonymized.
Yep. So this has the Ethernet switch, and what you can see here, these little white things. Okay, I've got to fix this. I have to fix the batteries in my trackpad because I was just trying to use it to zoom on that image, and I can't. I am very dependent on the trackpad working to be able to do anything much on my computer. And they died as I was getting ready for the stream. Now, do I even have any batteries? I've got, maybe I don't. That could be annoying. Very annoying. I don't think I do. I've got plenty of AAAs. I have one AA that I can find in my box of batteries. I don't think I've got any other AA's. Alright, I am going to have to live with not having a trackpad, which is very annoying. It'd be nice if the trackpad was rechargeable and didn't use AA's, because it chews through them. They go through so quickly. Okay.
Amanda Thompson said, I did a redesign to ease of printing and assembly. I also emailed you a copy of the STL files yesterday.
Yes. Good. Thanks,
Scott
Amanda.
Miller said, batteries are dead because Steve and Steph use it as a dance floor when you're away.
Probably. Yeah, it'd be like a tiny little skating rink. They could slide around on it, like a tap surface. Tap dancing squirrels during the night. All right, so Amanda, is it okay if I open those STLs and pull them into, I don't know, a slicer or something? Hi everyone, today's project, 3D printing AA batteries. Donald says, remove the batteries from your toothbrush. I don't have an electric toothbrush, but it does make me wonder, what else can I remove batteries from? What else uses AA batteries? I can't think of anything off the top of my head. Okay, thanks. I can open the STLs. Very good. I am going to download that. Download, yes. Download. Oh, okay. So there is a 3MF file here, which is a Prusa Slicer project file. So, oh, which can, no, it can be open in Prusa Slicer, which is cool. All right. Does that work? No. How am I going to zoom without a trackpad? This is annoying. Can I do Command minus? No. Doesn't work in Prusa Slicer. Okay. This is going to be super awkward. All right. So this is one of the 3MF files, the 3D model files. Opened. You can see parts here for the end caps and the little roller with the retractor thingy. These parts here are the white clips that you can see in, not there. There you can see what I was looking for in LCSC. Get rid of that. Actually, let's do this, because if I close that window, I don't know what else it's going to show. What is there? Okay. Now what about there? No, I don't have any other. Okay. Good. Back to here. Randomness. It is chaos today. Okay, so these white pieces here that you can see, those are these little clips here. And then you can see the...
Amanda Thompson said, open the other ont, it is less confusing.
Okay, I will. Back to here. All right, I'm going to close that and open this one. Hang on, that looks the same. I'm going to close that one again and open this one just to make sure I didn't open the wrong one. Odd.
Jack's text said, Control scroll.
Control scroll.
Scott Miller said, chaos today. Unlike every other day.
Oh, yeah, well actually I don't even need control because I forgot this trackpad has a roller wheel on the side of it, and that roller wheel is zoom. Okay, so looks like these are the parts required. In fact, if I do this, will it move them? Yes. That makes it easier. Okay, so this is the parts required to make one of these cartridges, plus part of the front. So we can see that there is the front section that goes into the rack. So this is what guides the cartridges. And then there are 3 bits of tube for the cartridges that interlock into each other. And then there are the parts for the end cap. There's the part that goes on the back, which has the retraction mechanism in it. It's a little pull-out string thingy, like from an access pass thingy attached to your belt. The part of the clip that goes in the front with the locking mechanism, and the slidey bit in the middle with a little roller that the patch lead goes around so that it gets tensioned up correctly. Okay, so these are all the parts. And Amanda's plan is to put all of this up on printables or somewhere like that so that anybody can do it. Some Call It Fun said, does Mac have multiple desktops, one dedicated to stream? Oh, it's got multiple desktops, yeah. In fact, if I go sideways, I don't even know what I'm going to reveal. Oh, there's nothing on that desktop. This one has nothing on it. And yeah, it's got multiple desktops per monitor as well. So you can't see, and you can either tie them, like bond the monitors together, or have them as separate virtual desktops per monitor. You can't see my main monitor. You can only see a little secondary monitor, which is up on the top. This one that's being streamed is a little extra monitor. But no, I don't bother setting up a separate workspace just for streaming. I just open the stream and you get to see what you get to see. Insert custom G-code. No, go away. Would it print faster if you put all of the same height parts next to each other? Probably not. Oh, Wagon Load says, do you have a 3-volt power supply and 2 AA dummy batteries? Oh, and Keith H said, grab a mouse off another computer. No, I have a trackpad here. I have multiple pointing devices. It's just that so I've got a space mouse in front of me. I've also got the trackball to the right, so I can do pointers like no problem. You can see my cursor waving around there. Doing cursory stuff is no problem. I can do all the things I could do with a mouse, but what I find really useful is gestures on the trackpad. Doing things like the one that I use all the time. Well, the ones that I use all the time are the 5-finger pinch, which is used for opening Launchpad, and the pinch to zoom and panning. So zooming, panning, and launching I do with gestures off my left hand. I need to grow more hands for all the input devices, yeah. Henrik said, can't you just order AA pizza or something? Yes. So there is I think I mentioned this on a previous stream. Uber Eats is it Uber Eats? No, not Uber Eats. The major competitor, I can't even remember what they're called. Just started doing drone deliveries out of the big shopping centre just near me. So you can order a coffee or a donut or something, which reminds me, I've got donuts here. I bought them on the way in this morning and then I haven't eaten any. And yeah, DoorDash, that's right. Thank you, Crispian. So DoorDash has just started doing drone deliveries. So I wonder if I could DoorDash a pair of AA batteries and get them delivered by drone. And there would be more energy expended in the batteries of the drone to fly them here than the energy contained within the AA batteries that would be delivered. So it would be a net negative energy calculation. Wagon Load says, can't you program a touchscreen to work as a trackpad? Maybe, but like right now while I'm streaming? Stephen says, food delivery is so expensive versus just going to get it yourself. Oh, and Jacksek said, actually, it would print slightly faster as there's less fly moves. So this is referring to putting the things of the same height together. Yeah, that's true. So I think the issue is more, it's not so much, okay, it's the other way of looking at it. The way it was originally put was, wouldn't it print faster if the things of the same height are put together? Oh, I can't remember. Anyway, I think I misinterpreted it. I was thinking about it in terms of putting all the low things together. And no, the important thing is to put all the high things together. Because once the printer gets to this point, it is going to be printing some over here, and then printing some over here, and then moving backwards and forwards between the two. And it's an extreme move from one side of the plate to the other. So putting this over here, for example, would mean that it would finish printing faster because it would spend less time in transit between them. So there's an optimization that could be made. Anyway, that was just because I hit the auto arrange button, which obviously doesn't take that into consideration. It's probably, I don't know what algorithm the auto arrange button is using, but it's probably just based on the geometry of the footprints and minimizing the perimeter. Although if you wanted to minimize the perimeter, you would take that and put it over there. Would be one slight improvement because that's within the perimeter and it reduces this loop here. Anyway, and then that could go there. Yeah, plating things manually, you can usually do a much better job than the auto plater. But the auto plater is convenient as a starting point. It just chucks everything in and gets it all spaced apart, and then you can tweak it and adjust it. Mr. Fix-It! Mr. Fix-It! Welcome! Scott says, auto-arrange algorithm by Google. Yeah, Wagon Load says that is what I meant. Yeah, so Wagon Loads was thinking about it the correct way. I misinterpreted the comment. But yes, you are absolutely right. Arranging things to have these things closer together would be an optimization. Kicking slowly here, was very cold overnight. Yeah. Rob V says, here power's on the 253 volt limit. Any weekday the sun's out. Only resident on a transformer full of holiday houses, many with solar. Have become quite familiar with replacing blown PSU caps. Ooh. Yeah. Managing supply of power must be quite a job. Yeah. It's a problem space that I know almost nothing about, other than the fact that it is very tricky, because what you're dealing with is variable load that like load that can vary significantly and you have no control over. It's all an aggregation of many people doing things across many houses, turning appliances on and off, and yeah, trying to push the right number of electrons. No, that's the wrong way of putting it. Trying to have the correct number of Coulomb people running along the insides of those wires at any one moment to keep the voltage stable. It would be quite quite a tricky job. So Gavin said, okay, so this is a question for this. All praise to Amanda, but aren't most switch ports stacked by 2 vertically? Wouldn't that halve the patch cable capacity? Yeah, but then you'd put one on both sides of the switch, maybe? Hang on, let's just go back to, where are we? Back to the photo. Okay, yeah, so in here you can see this switch is double stacked. So it's got double height 8P8C modular connectors. I'm not going to call them RJ45 connectors because people would tell me off. So yes. Oh, I can't zoom with this. Damn. All right, what about shift and then do that? No, that doesn't work. What about control? No, that doesn't work. Maybe shift command plus. Yes, shift command plus works. But then can I move it? Oh, I'm still in tool mode. What about, is there a hand tool? I don't know. I'm going to have to just do it this way. So you can see here that the sockets are double stacked. So what you could do is either put a patch box on both sides, or yeah, I suppose that's the logical thing to do. Stephen W says, I have a patch directly above and below the switch. 15 centimeter patch cables, one patch is all odd numbers, one all even. Oh, Mr. Fix-It said, by the way, John and Sion, thanks for the help. Rebuilding is going well. That's good to hear. So I mentioned a couple of, I think it was 2 streams ago, it might have even been 3 streams ago, that Mr. Fix-It had a really bad house fire which destroyed his work area among other parts of the house, and has a crowdfunding thing. I don't have the link handy. Mr. Fix-It, feel free to drop the link to your fundraiser into the chat. And yeah, if anybody feels like contributing a little to help Mr. Fix-It with rebuild, please send some dollary dues his way, because it looks like his house is a mess. It's a lot of damage from that fire. Yeah, so Amanda says, yeah, so I'll be having a patch above and below the switch. Yeah, so it'll make it nice and neat. Scott said, what's real fun is dealing with a pair of 24-port switches in the rack. People keep asking why one of them is installed upside down. Installed upside down. Upside down. You know what, it's never crossed my mind to install stuff upside down in a rack. I'm now pondering in what situation that would be beneficial. How? No, I can't think of a reason. I've installed stuff vertically in a rack, as in, well, I've installed a rack rotated 90 degrees so that everything mounts in it vertically. That can actually work out really nicely in a small cupboard sort of installation. Stephen said the ports being on the end of the device. Yeah, and some call it fun says keep all the electrons from falling out. Yeah, they have a habit of doing that. Yeah, do I have, I do. Hang on, I'm going to mute you for a second. No, I'm not going to mute you. I'm going to mute me because I am going to take a swig of coffee. I need this. And I know that it sucks to hear me drink, so I mute. Gavin said, so are we talking 5RU for 24 ports? 5RU. So the patch panel, how many? Well, that's actually a good question, which I'm sure I could answer just by looking. Amanda, how many cartridges do you fit in 1RU? And if we come back to the plater, so what have we got here? My guess, this is purely a guess, Amanda can tell me if I'm wrong, is that this is half of the holder. 24, thanks Amanda, yeah. So we're looking at this, 1, 2, 3, 4, 5, 6. So that is 12 in that. So what you would do is print that twice, and you can see that on the end here, Amanda has very cleverly designed that so that it's got these little alignment keys. So if you print 2 of these and then join them up end to end, you can glue them together, and these little keys slot into each other to keep them aligned. Very cool. Nice work. And so you end up with 24 slots, or the potential for 24 cartridges per rack unit. So if you've got a 24-port Ethernet switch, you could put one of these patch boxes directly adjacent to it, or if you've got a 48-port switch, you put one below and one above, and that will give you all of the patch leads that you need for the switch. Dodgy said, are you a noisy coffee drinker that you need to mute yourself? Well, not especially, but there have been times in the past where I think I had a bottle of water and I was drinking from that on a stream, and because the microphone is like, it's a bit hard to see at the moment because it's a black microphone against a black jacket, but it is right here near my throat. And when I was drinking, someone on the chat was complaining that they could hear it going glug, glug, glug. So now, whenever I take a drink on the stream, I mute myself. Gavin said, patch, cable management, switch, cable management, patch. Yeah, that sounds like the sequence. Dodgy said, looking at the keys, wouldn't you need a left and right design? And that's a good question. So that would become their, yeah. Yeah, they switch as you rotate it. So if you did a second one, in fact, what we can do, I'm just going to delete a whole bunch of this stuff. And I'm going to add another one of these. Let's see this. Then I'm going to go that. I'm going to rotate it like that, not to 90 degrees. And then I'm going to take this and I'm going to rotate it like that, not to 90 degrees. Move it to there. And then we can do this and zoom in. And there we go. Look, you can see that that same part duplicated and printed twice. Once you rotate it, the positive side on here matches up to the negative side on here, and vice versa. So you can print that one part and print it twice. When you rotate it, the keys match up with each other. Very nice. Gavin said, Scott says, if you're muted, we won't know to call for help if you choke on your coffee. Yeah, but you can still see me. You can still see me going. Gavin said, I would drop the car left and right ones as switches normally are centered and have space at the ends. Drop the, oh, far, sorry. Took me a while to parse what that was meant to be. Drop the far left and right. So instead of being 24 port, make it 22 port. But typically you need 24 ports. Yeah, Stephen says you need them all to get 24 cables. Yes. Anyway, very cool. Hang on, I can feel a sneeze coming on. I'm just going to see if I've got tissues nearby for when the sneeze happens. It's not happening now, but I just wanted to be prepared for it. Oh, there was a pin header on the floor. Oh, which reminds me, I just looked over and saw that and saw this new label printer. I just got this during the week and maybe that is something to show. It is very, very cool. Yes. Scott says, more common for 24 port switches to have all the ports offset to one side. Yes. But there is a minimum width you need. So ideally, what you would do is make each of these cartridges thinner. However, there is a practical limit to the minimum width you can make one of the cartridges. So if it's divided evenly across the 24 slots, across the full width of the rack like this, it all fits nicely. But if you yeah, I mean, hypothetically, ideally, I don't think this is necessarily practical. If you could make these significantly thinner, the slots, what you could do is align them all towards one end and leave a gap at this end. However, I don't think you could really make these significantly thinner than they are already. There are limits because you've got the width of the cable, and you can't use regular round cable. It's flat Ethernet cable, flat patch leads, because it goes down and around the roller at the back and comes back again. So flat Ethernet cable is wide, and then you've got physical restrictions in that you've got the thickness of the walls of the cartridge, there are the thickness of the dividers, there is the roller, there is the retraction mechanism, there are all of these things that essentially dictate the width that you have to make it, and you can't really just compress it down significantly. Well, that's a good idea. Scott said, Scott's suggestion for Amanda is you need to add a blanking plate to the design set for people that don't use all the slots. Yeah, that would be cool. It would be a very simple little thing, just a little blanking plate that clips in, and you could either make a a blanking, like a multi-unit
Amanda
blanking
Thompson
plate.
said, I am at the limit now of the printable with maintaining the structural support.
Yeah. So Amanda just made the point, I don't know if you could hear that on the text-to-speech, that she's already at the limit. You can't really compress this more because of the limits of, just the mechanical limits of the structure and making everything supported. Okay, so Gavin said, split it into 3 modules rather than 2 parts, have 3 more options. Yep. So this is the classic part of a project. I find, all right, I'm going to get slightly philosophical here for a second. I find that showing projects that I'm working on, showing them publicly, is a double-edged sword in that people have different ideas about how things should be done. So it's very easy to, I'm just thinking about how to explain this. It's quite scary to show your work publicly because people will always have other ideas about how it could be done, how it should be done, how it could be done better, how it could be done differently. And so first up, I just want to give props to Amanda for being willing to share all of this and let me show this work in public. It is a very, very cool project. And so this is the thing. And this is one thing where I think that this community is really good. You can have a few different reactions to this. You can have people who have very strong opinions about, no, that you shouldn't have done it that way. I would have done it this way and you're wrong. And that can feel really confronting. And there are also people who just come up with great suggestions that I would not necessarily have thought of myself. And that's where, Scott's suggestion, for example, about adding a blanking plate. I don't know if Amanda has thought about that already or not, but I found this with Testomatic and with various other projects that I've worked on where people will look at spend 5 minutes looking at something that I've been working on for a week and come up with an idea that never even occurred to me. And I actually really like that. It's, but you have to be prepared for it. You have to have a state of mind where you don't take things personally and take suggestions as, don't take suggestions as criticisms.
Say you're wrong. Ask them to show their design.
That's right. So Scott says, best answer for those who say you're wrong, ask them to show their design. Yeah, this has happened to me a couple of times. Like there have been times in the past where I have got so riled up by YouTube comments. I actually stopped even reading YouTube comments largely. There was one comment, this was a couple of years ago now, where someone, I did some video. It was one that I think I spent about a week working on it and published it, and someone made some comment about this video is a piece of crap, you talk too much, or something like that.
Amanda Thompson said, just designed the blanking plate and I'm printing it for testing now. Thanks for the suggestion.
Excellent.
Peter Lawler said, YouTube comments are almost as bad as live stream chat.
Almost as bad. Not quite as bad as you though, Peter. So anyway, this person had made this comment about, this video is dumb, you talk too much. And I I try to just totally ignore those sorts of things, but at some point so I clicked on this person's profile, like on the comment in YouTube. It had a link to their YouTube profile. So I clicked on that, and they had published, I think it was 2 videos. They were both like recording games they'd played. One of them was like a half-hour video of just some gameplay with nothing else. And like their total contribution to the field was 0. And I made some reply, I made a comment in reply that was something like, yeah, so once you create your tutorial on this subject that is better than mine and publish it, please let me know, because I'll provide a link to it. Yeah. Anyway, what is the point I'm trying to make? The point I'm trying to make is that it has taken me, it's taken me a while to become comfortable with showing my designs publicly and taking feedback and accepting, hang on, I'm just going to, oh no, I'm not, I'll leave it on. Scott says, I never get bad comments on my videos. Oh, right, I don't publish videos for public consumption. Oh, I just saw Peter's other comment. Their face is dumb. Yeah. Any Mule said, blanking plate is a great idea, especially for hot and cold aisle racks. Yeah. For those of you who have not worked in data centers before, they are one of the typical strategies, cooling strategies in them, is to have alternating hot and cold aisles. So the airflow for the cooling system flows through the rack in one direction, like from front to back. So what you do is you have an aisle with a whole lot of fronts. So you have 2 fronts facing each other, and then you have another aisle with 2 backs facing each other. So you have hot aisles and cold aisles, and airflow needs to be directed through the racks from the cold aisle to the hot aisle. And you don't want the air flowing through cavities in the rack. You need to direct it through all the places the air needs to go. So any holes in the front of the rack need to be blanked off and covered off to prevent air going through them. And that forces the air to flow through the cooling vents and all the places that you want it to go.
Peter Lawler said, my only comment regarding what I think is terrible is your live stream thumbnail. Nowhere near buff enough.
Yeah, nowhere near. Thanks, Peter. Superhouse project. Sorry, I'm at the same time as doing this, I'm opening Testomatic. I showed this last week, I think. Yeah, so these have actually gone off for production now, these boards. Anyway, this is the, no, actually I did some things after the last live stream. I've made some more changes. So, but this is how it has gone off to production. Why is this being so laggy? My Space Mouse is being super laggy.
Scott Miller said, or maybe too buff for a proper nerd.
Dodgy says, you should only give comments consideration if they add value. If they only want to crap on you, ignore them. Yeah, I know. That's what I keep telling myself. But it can be emotionally very difficult to ignore them. Yeah. And I know this is getting slightly off topic, but you see a similar thing I see this in sports all the time. Someone will be at the top of their game, the peak of performance, top, like best in the world, and people will be sitting on their armchairs at home, watching them on TV, eating popcorn and criticizing them. Like, get off your ass and do better before you offer criticism. So anyway, this has now gone off to production, and I should have PCBs this coming week, which is going to be kind of frustrating because what I don't have are any of the test boards to plug into this. TM mod test. In fact, let's open this. I haven't sent this off for production yet. Simon, you're here as well. Welcome. Oh, Dodgy says, why let someone create doubt in your mind when they can't do better? Yeah. Yeah, I know. It's easy to rationalize that and say that, but it is harder to emotionally decouple yourself, particularly if you have put a lot of work into something, and then when people see it, the first thing they do is start providing commentary on it. So I'm not saying, okay, I need to clarify. I am not saying here that, and also I can't speak for Amanda. I have no idea what her feeling is on this. But I'm not saying not to give suggestions. The reason that I show things like this, and the reason that, one of the reasons at least, that I do these sorts of things in public and let all of you participate in this process, is the ideas that other people have are almost always better than the ideas that I have. And by opening my work up to external review and input, it makes it better. So I win in the long run. But it can be confronting when I open a design and then a whole bunch of people say, you should do it this way, you should do it that way. But this way, yeah, I've got to decouple myself a little bit and think objectively, is that a valid suggestion or is it or not? And I think I'm a lot better at that now than I have been in the past. I find it much easier now to accept feedback and constructive criticism than I have in the past. And but it's something that I've had to work at. I've had to kind of throw myself out there and be willing to accept the suggestions. All right, so all of this is a long-winded way of saying, Amanda, the things that people suggest to you when they see your design, don't take them personally. Don't take it, or say, don't take it as criticism. Take it as alternative perspectives and other ideas and potentially different use cases. So yeah, I think different use cases is where I really get benefit from. It's when, oh, actually, does this need to be updated? No. That's interesting. Last night, so see this PCB under here, this one here, this test breakout. I actually edited this last night. Maybe I didn't save the 3D because I've replaced all of these pogo pins with holders. I have rethought the way I'm going to do these modules and I've moved it into a two-stack, like a two-layer design with holders in place of the directly soldered pogo pins. So Dodgy said, exactly, look at the suggestion, not the tone of the message. Some people are more abrupt than others, doesn't mean the suggestion is no good. Yeah, that's right. That's right. So, Yeah, that model is definitely out of date. So that is, where is that? It is Canva tester. That one? No. Oh, that one. Yeah, that there is out of date. In fact, the name isn't even the same anymore. So, your face is out of date. Yes, Peter. Sure is. Yeah. So, all right. I know I'm really hanging. I don't like the word harping, but I'm really hanging on to this subject for a little bit. Okay. Let me put this a slightly different way. When I put stuff up, like when I'm working on designs like this in public, I welcome feedback. Don't hold back. If you've got ideas and suggestions, or you look at this and think, oh, you've made a mistake because you haven't thought about this, or maybe this was a bad design choice, you could have done it a different way, please say so. I consciously put these things out here. I do these streams with my designs made public as a matter of choice. It's my personal choice to do this. And so I welcome that feedback. I may dismiss it, or I may not understand it. That's happened a few times. People have...
Peter Lawler said, my suggestion is send me breakfast.
Yeah, I like that suggestion. Breakfast. So where was I? Yeah. So for me personally, I put these things out there and I expect that people are going to come up with ideas and suggestions and make me rethink my assumptions, which is how we ended up with this design. Like if we look back in history at where Testomatic was, you look at the first version of the Testomatic board, the one that is currently running in my test chassis, it is nothing like this. It's been ripped apart and redesigned almost from scratch. The whole architecture is different. The way the I/O is done is different. The power strategy is different. The connector strategy is different. This is all inspired by feedback from the live streams and from people in the chat. And it's better for it. It is way better than the first design that I did. So there are enormous benefits to doing this sort of thing publicly. Okay, so that's speaking for myself. The caveat to that is when I show other people's designs and when people such as Amanda are generous enough to allow their designs to be shown on these streams, you just need to be conscious of the fact that they are also putting themselves out there and opening themselves to scrutiny and their designs to scrutiny. So just be conscious of that and be kind.
Wagon Load
please.
said, look at my last question.
Okay, what was your last question? Wagon Loads, scrolling back. Okay, is your Testomator always going to be plugged in, or is there a use case where you will need to move it while it is powered? I never thought about that. Move it while it's powered. I don't think so, because the normal use case is to have it as part of a production process where the tester is not a thing that is used in isolation. It's on a bench with trays of boards, and there's like an inside and an outside. So a whole lot of boards that haven't been tested, and then they get tested, and then they go on to pass or fail trays on the output side. And there's other stuff going on. There's a label printer attached to it. There are cameras and other things. So I don't think it'll be moved. Now the way this is designed, you can see here I've got V in 12 volts. So nominally I'm going to be running this off 12 volts most of the time. Sometimes I'll be running it off 24 volts. And so what you could do is just plug a big battery into the back of it, and you could run the whole thing off a battery. So it could be portable. My plan is that I'm going to be powering the test chassis off a lab power supply. So right now where my Testomatic version 1.0 is sitting on the bench down there, there are 3 lab power supplies sitting on the shelf just above it, and one of them is plugged into the Testomatic, and that's what's running it. So you don't have, it's not 240 volts plugged into the back of it. It's an XT60 connector with a lab power supply plugged into it. So I'm curious, Wagon Loads, about the context for the question. Are you thinking of a use case where the tester would be portable or used in a different situation? So yeah, I'm curious. Scott said there's more squirrels in the chat than in the stream itself. Weird. Yeah, that's probably because I have not really been reading the chat much, so I haven't been as distracted as I normally would be. Likely it wouldn't be bad to give it, say, a mean volt. Okay, so Scott says, likely wouldn't be a bad idea to just give it a dedicated PSU, say a mean volt 12 volt block. Yes. And Any Meal says, do you take the tester to the client? No. I had never even thought of that use case. I can imagine that some people would want to do that. Okay, so Scott says, wouldn't be a bad idea to give a dedicated PSU. Yeah, you could do that. You could just get like a mean wall power supply and mount it in the back of the chassis. But one of the reasons that I'm using an external lab supply is that it means I can take advantage of its built-in current limiting functionality and the fact that it gives a reasonably precise and clean output. So if I'm feeding 12 volts into this, I want 12.0 volts coming into it. Yeah. Oh, Crispian says, perhaps in the case of multiple failures. Yeah. This is interesting. I had never really thought about this before. But normally, in a case where you are diagnosing failures...
Outside the box said, how long does the test take? Amanda Thompson said, did you see my last chat post above?
All right, I will get back to that. How long does the test take? I'm just going to check back on Amanda's thing. So where was that? Scroll doesn't work. Back to there. Where was that? Okay. So Amanda said, I'm in the process of setting up to have my own YouTube channel. The plan is to start in October this year after my trip to New Zealand. Cool. Well, good luck with that. Yeah, that would be really cool. But just as a warning, all of the caveats that I gave earlier about showing your work publicly apply to a YouTube channel. So, yes, be prepared. Where was I? That's right. So Crispin was asking, how long does the test take? That is very much an it depends question. Sometimes, the thing is that I say this as a tester, it's also a programmer. So it can do the job of loading firmware and running tests. In the case of testing a small module that is very simple and doesn't have any firmware, such as a breakout for one of the things that I have testers for is a another example, not just a breakout. Imagine you've got a sensor on a board and it's I²C, so it's a little modular sensor, and you want to be able to test it. You don't need to load firmware on it, you just want to be able to initialize it, take a reading from it, verify that the reading makes sense, and you're done. That process from the time the test starts to the time it finishes might be half a second. So you've got to mount the module in the thing, press go, like half a second later the test is done. It knows if it's communicated, if it's been able to initialize the device or not. Other times, it might take several minutes to run a test. So I'm thinking the worst case scenario, probably the longest tests to run that I envisage myself doing with this will be the motor drivers in the water cannon controllers. And that is because I want to load them for a period of time and see what happens to the temperature. It's not enough to just flash firmware onto them and run them and see if you turn the motor on, the output goes high or low or whatever the thing is. What I want to do is have a dummy load hanging off this somewhere. So not mounted within the test chassis, but external to the chassis, there will be a dummy load, which could be either a programmable load or it could be as simple as a bunch of big wire wound resistors in a box that when you apply, say, 24 volts to it, it's going to pull 4 amps or whatever and just dissipate that energy. So it's a box that consumes power. So you connect that to the output of the motor drivers, and then you run the motor drivers for, just got a message from Gav. And then you run the motor drivers for a period of time and you see how warm they get. And ideally you want to run them for long enough that you have a stable temperature. And that might take 2 seconds, but it may not. It might take 30 seconds. And if you've got multiple motor drivers, it could be that running a full cycle test on one of these boards, it might take 5 minutes. So you clip it in, press go, and then you walk away and leave it. And the tester loads the firmware, runs test cycles, it loads up the motor drivers, it runs them until they're at a stable temperature, uses the thermal camera to measure how hot they've become. So what is the maximum temperature of the motor drivers? And then log the max temperature as part of the test results. You could log the curve of them getting hot over a period of time, like how fast they heat up and then where they stabilize. So the where was I? Yeah, sorry, I just got distracted by chat for a second. So this was all in response to Crispian's question about how long does a test take to run. The answer is between half a second and 5 minutes. And in some cases, people might want to run these for longer. You might want to heat soak, for example. You might want to have something, you might want to put something in this tester and have it run automated tests, like cycling it over the period of 12 hours or whatever. I don't know. There are all sorts of use cases for this type of device. Now the goal is to make the tests run as fast as possible, because you want to have throughput of how many devices you can test on this. But sometimes you want to use this in a situation where it's just going to take time. Oh, okay. So Gavin said a suggestion from Amanda, add some 2040 black extrusion, would add lots of strength. That was the phone message. Okay to show. Oh, right. All right. Let's, I'm just going to, I just tried to do the pinch to open the launcher thing. Messages. I want to see what this message from Gav was. Here we go. Oh. Oh. Okay. Hang on. I'm going to bring this photo up on the screen. There we go. So that is some 2040 extrusion.
Wagon Load said, would the test or device be ruined if you had a power failure during the test or firmware upload?
Oh, that's a really good question. All right, let me get back to that question. But yeah, so this is 2040 extrusion used between, are these 3D printed? It's a little bit hard to tell from this photo. And it looks like this panel is 3D printed. I can see layer lines on there. I'm not sure about these other parts, these bits of the box. If it is printed, the quality looks very good. It's a nice surface on there. Yeah, okay. Thanks, Gav. Yes, PLA, says Gav. Cool. Oh, and Paul asked, is there Wi-Fi functionality to communicate between testers, e.g. testing either end of a comms link? Oh, all right, some interesting ideas here. So getting back to the suggestions for the tester. So Wagon Loads asked, would the test or device be ruined if you had a power failure during the test or firmware upload? I think the short answer is probably not, but potentially it would not be good. Because the thing is, this tester is running on a Raspberry Pi, booting off an SD card, and if it was busy writing to disk at the time and you turn off power, you could end up with the corrupt SD card. So potentially there is that danger. In terms of the device, if you had a power failure partway through uploading firmware or writing or doing a test, typically the device under test would not be damaged because all you would do is start it again and upload the firmware again, and then you'd be okay. Unless you're it's possible there are edge cases, like imagine you were flashing devices that had an ESP32 and you were using secure boot and an encrypted bootloader, and you were partway through the process of encrypting the flash memory and then the power went out. Maybe you would end up with a bricked ESP32, I don't know, but that would be a very unusual situation. You'd have to have the power fail at exactly the right moment. So running this off a UPS is possibly a good idea, just to be on the safe side. Yeah, okay, so comms. Now, what Paul had a very interesting idea here. So, Paul said, Scott had the same suggestion, worst case, run it on a UPS. Yeah, so Paul said, is there Wi-Fi functionality to communicate between testers, e.g. testing either end of a comms link? Well, there are two approaches to that. One would be that you attach both ends of the comm link to the same tester, which in most cases would probably be practical. But if it wasn't, then yes, you could have two testers and have them synchronize if you wanted to, because this has the Raspberry Pi in it. What I'm going to do is bring Ethernet to the back of the enclosure. I have some of those little Ethernet extension panel mount leads. Hang on, I do actually have some here, but I'll see if I can find a picture because that'll save me wandering around looking for them. Panel mount patch. No, panel mount. Oh, this sort of thing, kind of. It's not quite... hang on, I've got a sneeze coming up. Here it comes. Yes, I forgot to unmute myself. After that last sneeze. But I'm unmuted now, I think. I am unmuted now. But I may have to mute again. My body is not cooperating.
Boo.
Okay, now I'm back.
Jack's text said, unmute.
Yep, I think I'm unmuted now.
Said, no sound.
Yeah, sorry, lots of sneezing happening there. I'm feeling more sick today than I did yesterday. This is not good. So this little patch lead it's a flying lead with a plug on one end, socket on the other, and it's a panel mount socket. I have a few of these, not these Data Pro ones, but some other brand, don't know what, no-name brand, something from AliExpress. So I'm going to mount one of those in the back of here. So there'll be an Ethernet socket in the back of the enclosure with the lead looped around and plugged into the Pi. And the Pi itself has Wi-Fi. So the Pi will be online. It will have connectivity and access to MQTT or whatever is useful. May also be useful for multi-board testing. Thinking of primary test. Paul says, thinking of a primary, secondary test units. Yeah. Yes, potentially. So if there is a use case for that. Now, one of my main use cases is going to be for testing these water cannon boards. And one of the reasons that they are hard to test is that they are part of a system. You can't run one of the boards in isolation because the motor driver, the thing that actually makes the water cannon move, drives all the motors and things and connects to the sensors. It accepts commands over CAN bus. It doesn't do anything on its own. You plug it in, there is no way to test it unless you connect it to a CAN bus and then start sending messages to it. So you need another device at the other end of the CAN bus to be able to invoke activity on it to be able to test it. Likewise, the input side, the joystick part that goes inside the cab of the truck, is a board with a joystick attached to it inside an enclosure with a CAN bus connector on it. And then when you move the joystick, it sends CAN bus signals over the bus that end up eventually getting back to the unit at the water cannon, and that's what makes it move. So I also can't test the joystick boards in isolation. They have to be connected to a CAN network and doing something to be able to test them. So my current test arrangement is I have a cannon. Oh, and this is coming back to a question from earlier. I can't remember who, sorry, but someone earlier, when I was talking about having an external dummy load, like to load up a motor driver, said, can't you use an actual motor and run the motor driver through the real motor to do the load testing? That is actually what I do right now. I have a water cannon, and those of you who have been, it's like right there over my shoulder. In fact, I've got two of them. There's another one down on the floor. Those of you who have been to the barbecues have seen the water cannon sitting here, and that is my test system. What I do is I get the motor, I have a known good motor driver and I have a known good joystick unit. So what I do is when I'm testing the motor drivers, I use my known good joystick unit, plug it into the CAN bus, connect up the device under test to the cannon, and I drive it around. I run the motors and test that the sensors are detected and all of that sort of thing. Likewise, when I'm testing the joysticks, I put the known good motor driver on the cannon, and then I plug my device under test, which is the joystick board, in to the CAN bus, and I use it to drive the cannon around to make sure that it's sending all the correct signals on CAN bus. So, okay, so all of this is thinking through this test process of multiple devices being tested with this. So this is my use case. Okay, imagine I want to test the motor driver of a water cannon. What I would do is have one of these modules, so the device under test breakout module, specifically set up to mount the water cannon motor driver in it. I would then have external connections to either actual physical motors or to a dummy load, or multiple dummy loads I would actually need, because there are 4 motor drivers in it. And so those dummy loads would...
Outside the box said, how much does wear affect its operation? Could there be substantial difference between your test unit and a field unit?
Ah, that is an excellent point. So Crispian said, how much does wear affect its operation? Could there be substantial difference between your test unit and a field unit? Yeah, and in a similar vein, does using that same unit for testing over a period of time mean that its behavior has changed? For example, wear in the bearings or something, that mean that the tests I'm doing now are different to the tests I was doing a year ago. Test reproducibility, that is a very good point. I'm not, maybe I'll get back onto that subject, but for now. So the scenario is the motor driver. What my intention is to emulate the behavior of the other end of the link.
Peter Lawler said, your face is a dummy load.
Oh yes, I load dummies up with my face. So, so scenario of 2 devices. Where's the camera? There. 2 devices connected by a CAN bus, so they are talking to each other. One of them is sending commands to the other, and the other is reading sensors and sending data back. So it's a bidirectional communication, and I need to be able to test one of those devices. Spit the dummy, yeah. My plan is to emulate one of the devices in both cases. For the motor driver, what I would do is mount the motor driver on here, and then I am going to have the test unit, so the Raspberry Pi, have a CAN bus communication and pretend to be the joystick. And so what it's going to be doing is sending command packets over, or frames, to use CAN terminology, over the CAN network to the motor driver to turn on and off different outputs and run them at different speeds, etc. And to read back the messages coming from the motor driver to see if it is detecting its sensors correctly. So it's reading its sensors and getting the values back from it. So there won't actually be a joystick in the system at all. There'll just be the motor driver, and the test unit will be pretending to be the joystick and send the commands as if it's the joystick, saying move left, move right, move up, move down, all of those sorts of things. And then it will be measuring the outputs of the motor driver to see if it is behaving and responding appropriately to those commands. So that's how the automated test will work. So I don't actually need 2 test units for like a joystick module at one end and the motor driver at the other end and coordinate them to be able to test those devices. That's my theory. Of course, this is all theory. I haven't done this yet on one of these test units, but this is what I'm working towards. So for my use cases, I don't see a need for multiple testers that will be linked and coordinated. Now, there may well be a use case for that. I don't know, but I don't think it applies for my particular use cases. Maybe other people will have uses for that. I don't know. All right. Paul said, I'm also interested in that scenario, but with Modbus. Ah, yes. Wagonlow says, if the motor had a pulley on it that lifted a known weight as load resistance on the motor. Yeah, that's true. That would be one way of doing it. However, yeah, so it could be done mechanically. You can create mechanical loads, but I think it's going to be sufficient to have external electronic dummy loads. So all solid state dummy loads. And Some Call It Fun said, how is calibration done on those units? Could the tester help? 100%. That is absolutely one of the things that I care about. And it's one of the things that is currently really annoying. So for those of you who, I mean, many of you will know this already, but for those of you who don't, the analog to digital converters in ESP32s have terrible calibration from the factory. Once you have calibrated them, they're actually pretty decent. They work well. But you can have two ESP32s and feed the exact same signal into their ADC and get dramatically different results. And I can't, off the top of my head, I can't remember the actual numbers, but I remember noting at some point, oh, these are giving different results. I thought they'd be the same. And I went looking at the data sheet, and the data sheet certainly for the older ESP32s, like the ESP32D and E series, it's something like 20%, I think. Like it was some number that made me go, what the hell? That can't be real. The stated, okay, so there are differences, the words accuracy and precision and repeatability and all of these sorts of things have very specific meanings in this context that I'm not going to get into right now. You can have something that has very high precision but low accuracy, for example. You might get several decimal points of something out of it, but it's totally inaccurate. Okay, so my point is, if you calibrate or characterize the ADC in an ESP32, it's generally very good, but you have to calibrate it. You have to know what your reference point is. And that is really important for me in the case of the water cannon motor driver, because the limit sensors that it uses are Hall effect limit sensors that they are, what's the term? It's gone out of my head at the moment. Bidirection, yeah. Hall sensors can either deflect in one direction based on the strength of a magnetic field, or they can sit like at a midpoint and then deflect in either direction based on the polarization of the field. And I can't remember the specific terminology, and I'm sure someone in the chat will. So the limit sensors on the water cannons use these Hall effect sensors, and based on the polarization of the magnets that are used in the mechanism, the sensor can tell if it's hit, for example, the left limit versus the right limit, because the deflection of the magnetic field goes in the other direction. And setting the midpoint on those hall sensors is a critical part of the testing and calibration of the water cannon, so that it will reliably detect the deflection. So the ADCs in the ESP32, I calibrate. I have a routine in the firmware that does calibration on those ADCs. And the way I invoke that at the moment is that there is a pin. There are two ways to invoke it. There is a pin on the board, which is a calibration input. If that pin is asserted on startup, the board runs its calibration routine. And to do that, you need to have a known signal going into the ADC.
Peter Lawler said, "Your face is a critical part of the water cannon."
Yeah, my face is very critical. This is my critical face. Yeah, so what happens is during testing, I provide a so the hall sensors have they are 5 volt sensors. So nominally 0 to 5 volts is the range, although in reality,
Miller said, "Peter is on a roll tonight."
yeah, in reality, what they do is they sit on the midpoint when there is no significant magnetic field affecting them. They sit on the midpoint of the output, so 2.5 volts is the output, and then it deflects above or below that. Oh, I've got another sneeze coming on. Above or below that, depending on the influence of the magnetic field. And so what I do is send a known 2.5 volt signal into the controller. It then goes into a voltage divider because the ESP32 is running at 3.5 volts. So it shifts the signal down. But the point is, I give it a known accurate 2.5 volt reference on the sensor input, and then I tell it to run the calibration routine. And it then sees that 2.5 volts and calibrates itself, and then stores it in EEPROM. And from that point on, it's good. It's consistent and fine, and it works every time. But you have to do that calibration routine. And that is one of the things I'm going to get this tester to do for me. I'm going to have it provide the 2.5 volt reference voltage, so an accurate reference voltage coming up on one of these test pins, going to the input on the motor driver, and then it's going to tell the system to run its calibration. So it'll load the firmware and then tell it to calibrate against that reference voltage and store it in EEPROM. That's a process that at the moment I invoke it manually. I connect it all up and I manually put it into calibration mode and it does its thing. I want to be able to put the board on the tester, press a button and just have it do everything. Load the firmware, test all of the motor driver outputs individually, calibrate the ADCs, test the ADCs by then varying that voltage to simulate a sensor being triggered in either direction, and validate that the motor driver responds appropriately once it detects that it's hit the limit. Yeah. Stephen asked an excellent question, which is, using a 2.5 volt reference voltage IC on the test board or via a DAC output? My plan is to do that using a DAC output. So once again, the caveat is this is all untested. This is all just my theory at the moment, and plans may change when I try and do it and discover problems I haven't thought about, because what I want to do is use a DAC output. So that's one of the reasons that on this, if we go back to here, so I've got ADCs. There are two ADCs here. So these are 12 or 14-bit ADCs, can't remember. And there is a DAC. So this is a 4-channel DAC. And on this version of the board, I've only populated one DAC because this is all partly design validation. I just want to see if this is going to work. So I've got 4 channels of DAC output here, and this is a 5 volt DAC. So in theory I can do 0 to 5 volts, although it won't quite swing to the rails, it'll go close. So I think it's like 0.2 of a volt up to 4.8 volts or something is the range I can get out of the DAC. My plan is to use that to generate an accurate 2.5 volt reference to simulate the sensor being in its untriggered state. And then I want to use that same DAC to move the value in either direction and validate that the motor controller is detecting that change. So I am going to use this to pretend to be the limit sensors. So there's an X limit sensor and a Y limit sensor. So we need to simulate two different sensors. Simulate the sensors. Simulate the sensors or stimulate the sensors. Hopefully it'll work. I really hope it works. I am so excited about this thermal camera, this low-cost thermal camera. I've got an idea for a project. Peter, keep them coming.
Peter Lawler said, "Your face is simulated."
Yeah, my face is simulated. Scott asked, how will you account for ADC drift after deployment? Oh, by the way, keep them coming, Peter. That's amusing me. I'm disappointed that you didn't say my face is stimulated. Scott says, how will you account for ADC drift after deployment? So far we haven't had any issues with that. We've had units that have been out in the field for years now with no drift. So, yeah. I think as I was saying, I kind of started saying, the ADC on the ESP32 is generally good. It's just calibration that sucks. It's lack of calibration. If they factory calibrated them before shipping them, they'd be great. But calibration is a job that is, it's like, this is left as an exercise for the reader. Yeah. Where was I? Oh yeah. There was a very interesting suggestion, actually, YouTube comment on the video from the last live stream. Was it the last one? I can't remember. One of the live streams, one of the recent ones, where I was talking about the voltage, these voltage regulators in here, and wanting to make these programmable power supplies. There was a comment on YouTube. Then, Paul said, sorry, I might have missed it, but is calibration stored? Yeah, I store the calibration in EEPROM. Yeah, I have my own calibration routine, which is, that's all right, Paul. I understood that you were saying calibration. So the calibration that I do is very simple. All I'm doing is setting a midpoint so that I know what there's effectively, not the 0 point, but the midpoint. I am taking the 2.5 volts input onto the 80, that then gets divided down, but on the input side it's 2.5 volts, and saying whatever signal you are seeing now, this is 2.5 volts. And then it takes the ADC value and it stores that, and there's a correction factor and things that end up being stored in EEPROM. So my firmware that actually runs the Canon loads
Peter
that.
Lawler said, my calibration routine involves coffee. Lots of coffee.
Yeah, my calibration routine involves coffee too. So it takes that value, on startup, it loads that value from EEPROM and it uses it in its calculations whenever it's reading the ADC. It applies those corrections to it. And it does that for voltage sensing as well. Storing celebrations would make them less fun. Might even, yeah, there's this whole chat going on at the moment. A back channel conversation about celebrations in Tassie next Sunday. Okay. Where was I? I don't know. Yeah. Oh, that's right. I half made the point earlier that I've ordered these boards. So these PCBs are currently being fabricated, and I'm going to get them sometime during the week, probably. I guess they'll arrive later in the week. And I have all of the parts to assemble them, but I don't have anything to plug into it. Like, I don't have any test breakouts that are built to this new standard with the card edge connector on it. And this is something that I was just messing around with. I need something to test the tester. So these LEDs, this set of 24 LEDs, are connected to the GPIOs, the GPIO pins from the tester. These resistors that you can see down here, these are looping back between DAC outputs and ADC inputs. So there's nothing special about these resistors, they're just for current limiting. I could have just looped around a track from, you know, one of these outputs to the inputs.
Said, make a test breakout to test the tether boards.
Yeah. Yes, that's right. So what I could do is make a version of this that takes it back to the IDC headers. But the thing is that the boards that I have that have the IDC headers are now getting to the point of being obsolete anyway and needing updating. So when I update them, I might as well update them to use the new header format. Yeah, so what this does is, also, what I have in mind is creating templates for other people to use. I want to, so all of this is public, of course. All of the designs will be on GitHub and under an open license, so you can do with it what you will. I want it to be as easy as possible for other people to take this system and build their own test modules for their own devices under test. So what I'm going to do is include templates for breakouts, so that you can then just load this up and modify it. You can add the test points you want, you can do whatever you want without having to create everything from scratch. And so I've got LEDs on here to show power. So there is constant power, 3.3 volts and 5 volts, which is used for by the tester itself, and it exposes those voltages are exposed on here. And there is switchable power for V in 5 volts and 3.3 volts for the device under test. This is all controlled by the tester, and this will give a visual indication of when those power rails are turned on. This is the EEPROM, which identifies the test module. It's the 24C32 I2C EEPROM, same as used on Raspberry Pi hats and other things. And that is on the main I2C bus, along with all of the other I/O, so that the Raspberry Pi can query it and find out what test module is installed, so it knows what type of device it's about to be testing. Yeah, and as I was saying before, these resistors are just looping around. The value of them doesn't even matter.
Scott Miller said, but will you make a KICAD version of the template?
Oh yeah, absolutely. I am going to definitely be doing this in KiCad. Yeah. Yeah, this is just my quick tester, but I'm going to do a proper template. In fact, what do I have open here? Testomatic tester. I'll open the schematic. So I've been thinking ahead to make this as easy as possible for people to adapt to their own purposes. This is Open Managed Libraries to update. Yeah, not right now. So I've got the big card edge connector in the middle here with all of the signals coming off it. And I really wish I could. Can I drag that way? No. Can I drag with that? Yes, I can. Okay. All right, so the idea is that you should be able to open this as a template or the KiCad version of this or whatever, and you've got all of the signals exposed here so you can see what they are, and then you can just hook up test points to the appropriate signals. And you can see here I've just got a bunch of LEDs connected to each of the GPIOs, but they could be going to test points. I've got the loop back resistors here going between DACs and ADCs, so I can generate a voltage. I can generate a signal on the DAC, and it goes through the resistor and then into the ADC input, which is labeled vSense, but it should probably be labeled ADC or something. Yes, bad terminology. Power LEDs, ID, the EEPROM. But what I want to do is have it so that this template is really easy for people to use as a starting point to make their own test breakout. USB, yes, Paul, Peter said something else funny. John's face is a testy. Okay. Paul asked, do you break out a USB from the Pi for device under test, e.g. tiny tape out breakout board is driven by a USB-C, also ESP dev boards? Yes, that is an excellent point. I'm going to take this off the screen because I'm going to show you something, but I've got to go into, hang on, before I do that, do I open that? I'm going to open something else. I'm just going to prepare a couple of things so I can show you, but one of these is client specific. So I'm going to open the board, but I'm not going to show you the context. It's one of those situations where I can show you some things, but I can't show you everything. There are other things outside of this context that the client may not want you to see. Opening. Come on. All right, opening. And then open this. I'm really pushing the memory on the device now. Okay. Come on. Come on. Back to here. Why isn't my space mouse working? Don't know. All right. This is all in service of answering Paul's question, because this is an important design decision. It's a radical change from the way I was originally thinking about this, and it came about. This change came about based on feedback on one of the live streams, and I think it has made this whole tester architecture so much better than I was originally planning, because my original plan was to include things like an ESP flasher, USB to serial converter, and all of those sorts of things, even a UPDI programmer in the tester. The problem is that limits what you can do, because you have those features and it's finite. What happens if you want two USB to serial converters because you want to talk to two serial consoles at the same time, and you've only got one in the tester? Then you're stuck. Now if I come back to here, so this is the tester, and oops, what you can see here is a big block of stuff for power. This is all the device under test power. Then there is a block here, let me zoom, which has the, it's got two I2C buses, and this I2C bus.
Peter Lawler said, 10 minutes to lunch.
Aha. So this I2C bus is available on the test breakout in case you want to put other things on there. Maybe you want to add extra I/O expanders. Maybe you want to add some PWM drivers. Maybe you want to add temperature sensors. All sorts of things. Whatever you want to put on I2C for your test to use can go on the test breakout specific to your device under test and communicate via I2C. Then there are 4 USB ports brought through as well. And that means, so if for example you have an ESP30, something which has native USB, so say your device under test has native USB. Say it's an ESP32S3 which has native USB on it, or an H2 or whatever. Then you can bring this one of these USB ports up and connect it directly to your device under test and communicate with it over USB. And there are 4 of them. So we've got 4 USB ports here exposed. And you can also, so what you could do is you could have one of these brought up and do a USB to serial converter on the test breakout board, if that's what you wanted to do. So say you've got a serial console on your device under test and you want to connect to that serial console. No worries. You got USB on the breakout board. You can put a converter directly on the breakout board. You could put 4 converters on the breakout board if you wanted to, because you've got 4 USB ports here. So that gives you flexibility to put an ESP flasher, you could put a UPDI programmer, you could do serial console, you could put whatever you want. Anything that'll talk USB, you can put it on the device breakout. So that gives you a lot of flexibility. And then there is also SPI. SPI from the Raspberry Pi is brought up onto the test breakout, and that will allow things like a CAN bus controller or I don't know, whatever you want to put on there that is SPI, you can put onto the test breakout. So yeah, my use case, one of the reasons I want this is I want to put a CAN controller on a test breakout for the water cannon boards so that I can have the Raspberry Pi that is running the tests communicating via CAN bus with the device under test. And then we've got the 2 chip enable pins. So Raspberry Pi has 2 chip enables designated, CE0 and CE1. They are brought up there. And then there are a couple of other spare GPIOs just for the hell of it. So if you wanted to use these as extra chip enables or something, then you can do that. And there is also one IO18, which is designated, there's nothing special about it, it is just another GPIO. But this particular one is designated for a reset for the test breakout. And what you can do is connect that to, say, I/O expanders on the test breakout so that the Raspberry Pi can manually reset those if it has to. So that gives you control of being able to reset devices on the test breakout. So I think this combination of things, like if you look at this block of I/O pins here, should give you all the flexibility you need to implement whatever test, whatever very specific stuff is necessary for your device under test. You've got I2C, SPI, USB, and a couple of spare GPIOs. And then there are...
Lawler said, John's face is getting fatter.
Thanks, Peter. I'm glad you noticed. Thank you. So then you've got the GPIOs, you've got the analog inputs and the DAC outputs. So that is what is going up to the device under test. Okay, now this is the interesting thing, and this is something that I was just doing during the week. In fact, I should have opened this already. No, you'll see it. You'll see it. Okay, so USB is brought up here. One of the really common use cases for me is programming old style ESP32s, which don't have USB built in, which means that to program them, I need something that's equivalent to an ESP flasher. So what
Scott Miller
I did...
said, John has lost the chat again.
I have lost the chat. I haven't been looking. I've just been on a monologue. All right. Now, where is it? IDE EEPROM. Oh yeah, that's the. That's actually not right. That should be.
Peter Lawler said, John's face is a flasher.
My face is a flasher. ESP flasher. Yeah, so what this got me thinking is, all right, so we've got this board. This is an example of a board that will be used for testing. Obviously, it's got a lot of routing to be done. That will be used for flashing and testing a device under test. So, as you can tell, a solar cam board in this case. And that particular board has an ESP32 on it that will need to be flashed. It's got an ESP flash header on it. So, one way to do that is that we've got USB coming up here on the card edge connector. What I could do is put a USB to serial converter on here. Basically, I could implement an ESP flasher directly on this breakout board. But that's going to be a pain. I just started thinking ahead to all the different things that could be implemented on this board. There is USB to serial, there is USB to ESP flasher, etc. Whatever. There could be other things. So why don't I make modules to make that easy? So I did. So what you can see down here, this module is the outline of an ESP flasher. This header up here is the ESP flash output that goes to the target. This is the input side, so this is USB data and power and ground. And if we look at this, you can see there is a module. I mean, I may not put it on the bottom, it may end up being on the top.
Miller said, could implement our RPI clone on the breakout board.
You could. You could do all sorts of things on the breakout board. But the goal is to keep the breakout board as simple and as cheap as possible, and to not have to require a whole lot of thought. Hang on, I'm going to show polygon fills. I'm going to push to 3D, push. Yeah, I don't want building this breakout to become a whole exercise in itself. I want to minimize the effort of making the breakout by pushing that work onto the tester, like onto the Testomatic, or onto modules. And the idea with this is, if you wanted to, you could implement USB to serial directly on the test breakout, but you shouldn't have to. If you want to make it easy, what you do is you just put down a footprint for one of these modules, and this, I mean, the 3D representation of the pins and everything is wrong, but this module is a USB interface on this side, and it is an ESP flash interface on this side. So it should be a matter of plonk down the footprint for the module and connect up USB, and boom, now you can program ESP32s on your breakout, and you haven't had to actually implement all of the circuitry that's on this module on the breakout. This should be a simple little add-on. And if you update your breakout, so you've got a new version of your device under test, you make a new breakout, you can just unplug this module.
Lunchtime.
Lunchtime. You can just unplug this module, plug it into your new one, and you're ready to go. Yeah, so my plan is to implement a couple of little modules like this, which are helpers. They are things that if you are building a test breakout, you might have certain functionality that you want to do and that's repeated. You shouldn't have to design that yourself from scratch.
Miller said, modularity is always good.
Yeah, that's right. You could just, Crispian says you could plug lunch into it. Yeah. I want it to be as easy as having a footprint, like a KiCad library with footprints for these modules as just as a single thing. You shouldn't have to even worry about the two headers that this plugs into. It should be a case of I have a footprint, and in fact that's what I have done in here. So I've already done it in Fusion. You can see in here, this device, this module, that is a footprint for the module. It should be a case of, oh, I want to be able to program. So what I've done is I've taken, and you can see I've still got to hook up a couple of test points here. You plonk down a single thing in your schematic, you hook up USB and power, you hook up your test points, and that's it, you're done. You don't have to worry about what goes on inside this module. That should be taken care of. So what I want to do is design modules for, yeah, the two specifically that I can immediately think of the need for is USB to serial and USB to ESP flash.
Outside the box said.
Some call it fun. Surface mount USB jack on the test board for off-the-shelf items. Yeah, definitely. If you wanted to, you could. There are a couple of things you could do. One is, if I come all the way back to, where is it? Here. No, not here. Here. There is a USB hub in the back of the test enclosure. So there will be USB ports exposed on the back, which will be used for things like plugging in the receipt printer and barcode scanner, whatever else you might want to plug in. But if you had some device, like it could be a USB to serial converter or a whatever, doesn't matter what it is, RS485 adapter, who knows. There are USB ports available on the back of the tester to plug that in, but you could also do it through the USB ports that are brought up onto the test board itself. So yes, if you had some other device that you wanted to plug in, you could put a USB socket directly on the board if you wanted to, using one of those 4 available USB ports. Stephen W says USB to serial and ESP flash could be the same module, you just don't connect the IO0 and RST. That is a very good, why didn't I think of that? That is a very good point. It is the same thing. Okay, that's just half the work. Brilliant. Thank you, Stephen. That's why I like talking about these things. People come up with very clever ideas.
Said, your face is hungry.
Your face is hungry. Just hang on, I've got to resize that window. There we go. What is going on out there? Oh, truck pulling up at the sawmill over the road. Yeah, Peter wants lunch. Peter wants lunch. Yes, you're right. You are absolutely right.
Outside the box said, Peter wants Lun TSCH.
Yes, you just don't connect IO0 and RST. Yeah, so what I need to do is generalize this footprint a little and make it more obvious that it can be used both for USB serial and for programming, for ESP programming. One thing that I had thought of, so this physically has the footprint on the output side. You can see that 2x3 footprint there. That footprint is the same as an ESP flash. So if you didn't have this module, you could just plug an ESP flash programmer into that header and it would do the exact same job. I was thinking of doing a USB to serial converter that on this side would have the 1x6 header.
Said, hey, I just realized, if I really wanted lunch, I'd just boot everyone from the chat tongue out.
And that was when John realized that giving Peter admin privileges was a mistake. He done stuffed up. So yeah, what I was going to do was have an FTDI header.
It took me how many hundreds of days to realize that.
Yep.
Scott Miller said, just change the title in that block, especially flasher and UBS to serial.
Yeah, yep. Okay, thanks Scott. I will fix that. But yeah, what I've been thinking of doing was on the version that was the USB to serial converter, I would give it a 1x6 header in the same format as an FTDI interface. The reason being that if you didn't have one of those modules, you could just use a regular USB to serial converter and plug it into the header and solve the problem. But that doesn't matter. I mean, when you're designing the board, you could just put a 1x6 header on here as well, and then you're covered in both scenarios. So it's not really losing anything. Yeah. Okay. So, ideas for other modules. I'm not necessarily asking for these right at this moment, but now that you understand this concept that the tester is designed to be modular and we've got USB and I2C and SPI brought up onto the test breakout, what other convenience modules might people want? Like if you were designing your own test breakout, I can imagine that people might want RS485 or...
Peter Lawler said, as long as you don't take away my meme channel on your Discord tongue out.
No, the meme channel is there to stay. Jordan said, isn't the ESP flash typically just an FTDI chip? Yeah, it is, with some extra circuitry for the reset, for the boot mode control. And in my particular case, so on my ESP flashes, I use a Scilab's CP2102N as the USB to serial converter chip, but it is basically the same sort of thing. Wagon Load said, do the USB ports have HID capability? Oh, Jack's Tech, CAN module. And Scott says another module, CAN transceiver. Yes! Why did I not think of that? I was thinking of implementing it directly on the PCB, but no, I should make it modular. Ah, yeah, okay, so what I need to do now is make myself up a little list of all of the modules that I might want on here. So we've already got USB to ESP and serial. I could do SPI to SPI to CAN. Yeah, okay. You are absolutely right. What I should do, the general design philosophy I should take on this is anytime that I'm designing one of these breakout modules, if they have active electronics on them, I should consider whether those electronics can be turned into a module for reuse. Yes. Trady Trev says +1 for RS485. Yeah, every part is a module, just in different form factors, says Eddie Mules. Jack's Tech said audio. Right. Stephen W says Max 485 chips are cheap. Just populate that on the test board and use the same USB serial module. Oh, okay. Yep. So that would be USB to serial and then the serial going into a Max 485 and then that gives you RS485. Okay. Now, the question was, Wagon Loads asked, do the USB ports have HID capability? Right. I've got to really stop and think about that. So for those of you who don't know, I'm sure most of you do, HID stands for Human Interface Device. So that is pretending to be like a keyboard or a mouse or some other input device, which could be very useful if you're plugging into something that accepts a keyboard or some kind of an input device, because then the tester can pretend to be that input device. I don't know. That would come down to the software running on the Pi. Can a Pi USB port pretend to be, can it be a HID? I don't know. I've never thought about it that way. Yeah. Oh, Scott said full spec RS232. Right.
Peter Lawler said, Pi o'clock.
Yeah, Scott said HID is entirely a software issue. Yeah. Stephen W. said doubt it via a hub. Okay, so that's the thing to consider, is that this is happening via a hub. Those 4 USB ports are going through a hub, which is on... I've got to close a few things because I've got way too many tabs open here. I'm going to close that. Close that. What's this one? Cam tester. Oh yeah, I'll close that. No, don't save. Not for now. Don't save. Don't save. Oh, I don't have the actual thing open. Okay, but the point is, the USB ports that are exposed up here onto the test breakout come from this chip here, which is a USB hub. So there's this little vertical USB-C connector. My plan is that there will be a cable that comes off this USB-C connector and plugs into the Pi, and that will take one of the Pi's USB ports and split it into 4 using this hub chip. So none of the Pi ports will be directly exposed up to here. Okay, that is an interesting one. I don't really quite know what to do about that. So that's a future problem. Okay. Yeah. I think I'm going to go. It's partly because I'm tired. As I've said before, I am still not feeling good. There are a few people who joined. Donald, Aft, Trady Trev. A few people who joined the chat after the original. Your donuts are getting stale. Yes. Trady Trev says, I look at most POS terminals and they have a bunch of RS232 ports and a touchscreen. Yes. Okay. Wagon Loads asked, is this on GitHub yet? Good question. GitHub. It certainly won't be up to date. I'm just having a quick look. There's definitely a repo for it. Updated last week. This is the repo. I'm going to drop this in the chat. I need a single verified email address. Okay.
Outside the box said, go have some rest, John.
Yeah, I will. But I'm just going to drop this in the chat. It may not be totally up to date. So, pin allocation. Yeah, it is definitely not up to date. Look at this. 2 months ago update on hardware. That is way, way out of date. So I need to fix that. There's a picture of my test system as it currently stands. Actually, this is how it is set up on the bench out the back at the moment. This is the version that I've been using for a while, and I need to add some more credits in here. I need to add credits for people that have made suggestions. So yeah, there is a repo, but it is way out of date. So I need to take the most recent stuff and start updating this repo. Because what we have now is way more advanced.
Scott Miller said, "Sink, damn it."
Yeah, it's way more developed than what is in that repo. I am really excited about this. This is an interesting and fun and challenging project and novel. Like, it's basically hitting all of the trigger points for my ADHD. And it has really sucked me in. I am so invested now in this tester and making it do all the things and making it as good as possible. Yeah, I don't know. I can't say much more than that. I am fully invested in this, and I'm having a ball working on this. Yeah. Right. Okay, so I am going to go and, yes, rest. Wagon Load says, looks like a lot of empty space in that case that could be used for a backup battery. You're right, there could be a backup battery in there. But what is not shown in this is that there is actually going to be physical structure protruding below this test module. I need space in here because there is going to be a whole extra layer. It's not shown in this, but there will be, this test module is going to come down like another 20 millimeters below this surface. There will be spaces and then another laser cut layer down below here and pins sticking down and things like that. So this space is going to be partly occupied. But I don't have this model fully up to date, so that's just why it is not showing that. I don't have this assembly up to date. Yeah. Anyway, yes. So I'm going to leave it there. Trady Shrev says, if you're having fun, you're having a good time. Yeah. This is what is fun in my life these days, building test jigs. Okay, I'm gonna go. Waves to Mike and waves to everybody else. Thank you very much for coming along. Keep thinking about modules. I am also going to keep thinking about modules. What else can be modularized in this and different use cases, and how can we make this a generally useful little project that other people can benefit from? Because I see this going way beyond just something that I build and use myself. I think other people could benefit from this. All right. Thank you, everybody. Also, a special thank you to Amanda for sharing the designs and
Scott Miller said, "Thanks, John."
and being willing to publicly share that sort of thing and accept feedback and suggestions. Yes. Good luck with that, and I hope that project continues to go very well. So, have a fantastic Sunday, and if you're in Melbourne and you want to see the definition of a perfect day, go outside. It is one, like right now. It is the definition of a perfect day. So, have a great week, and I will talk to you all really soon, and see some of you at the barbecue next week. Hooroo!